So you guys want to see my crib? Alright. Now you're going to hear a little bit about me and where I live. The solar system of Kepler 90. Kepler KOI 351H, otherwise known as Kepler 90H, is a recently discovered exoplanet orbiting around the star Kepler 90. Unearthed in 2013, it is a gas giant with striking similarity to a planet in our solar system, and is within the habitable zone of its star. Located 2,840 light-years away from Earth, it is inside the constellation Draco. It has an orbital period of approximately 331 days. This planet was discovered using the transit method. The host of Kepler 90H is its star, which goes under many aliases. We will refer to it as either Kepler 90 or Kepler KOI 351. Kepler 90 is a G-type main sequence star, which is the same kind of star as our Sun. In its core, it converts hydrogen to helium by means of nuclear fusion. It also has an effective temperature of around 680 Kelvin, or around 10,480 degrees Fahrenheit, which is about 300 Kelvin hotter than the Sun, which is 5,778 Kelvin, or about 10,000 degrees Fahrenheit. Kepler 90 also has an estimated age of around 2 billion years. What makes this star and its planetary system quite intriguing is how similar it is to our solar system. Like our solar system, Kepler 90's rocky planets orbit closer to the star, whereas the gas giants orbit farther away. In addition, both systems have 8 planets, with some of them having similar surface temperatures and orbital distances to those on Earth. Before delving deep into Kepler 90H, we are going to talk about how it was discovered, the transit method. This is a process that has been used to uncover a very large amount of exoplanets. In it, scientists observe a star and its fluctuating brightness through telescopes to determine if a planet is orbiting it. When a planet passes between a star and the Earth, it is called a transit. When this happens, the star will dim slightly. How much or how little depends on the magnitude of the planet and its host star. This dimming reflects the sizes of the planet and its host star proportionally. By using the formula V average equals delta x over t, or 2 pi r over capital T, because this is circular motion, with the displacement representing the length of orbit and the period representing the time it takes to complete that orbit, we can find the average velocity of this planet. Upon substituting for our given information, the radius of the planet, as well as the amount of time it takes for it to spin in one day, we can calculate that the average velocity this planet has is roughly 15.51 meters per second. With this equation, we can find the little g, or the gravitational acceleration on this planet. We can use the formula g equals big G times the mass of the planet over the radius of the planet squared. Upon filling in for our knowns the universal gravitational constant, the radius of the planet, as well as its mass, we could figure out that the acceleration gravitationally is 27.8 meters per second squared. Upon analyzing this, we can see that this is 3 times that of what we experience on Earth. Somebody who were to experience this force would be a fighter pilot, but only for about 3 to maybe 10 seconds. Otherwise, if it was longer, it would be lethal. Deducing this, we would come to the conclusion that humans would not be able to withstand these types of conditions. In our final analysis, we will determine the force of gravity between the planet and the star using Newton's universal law of gravitation. Upon substituting our known variables in the equation, we find that the force that Kepler 90 exerts on the planet Kepler 90H, and so vice versa, is 1.45 times 10 to the 25 newtons, which is quite a colossal force. Now, I know. At this point in the video, you are probably raising your hand incessantly, foaming at the mouth to ask me this one question. Is Kepler 90H habitable? The answer is no. I know, I know, a bit tragic. But, as you may have realized when I was stating my facts about the gravitational acceleration in this video, you probably would have caught on to this fact a little bit earlier. Other than the gravitational force that could pulverize any human that were to stand on this planet also has absolutely nowhere to stand on, due to the fact that it is a gas giant. However, what makes this planet so interesting is that it has many similarities to our planet in our solar system, Jupiter. While its mass has not been specifically defined, astronomers can safely assume that it is slightly less than or equal to 1.2 times that of Jupiter's, due to the fact that it has almost the exact same radius as Jupiter, as well as the fact that it has a very similar surface gravity, about 2 meters per second away from Jupiter's 25 meters per second. For this video, we will say that the mass is around 1.1 Jovian units. Furthermore, it is in a habitable zone of its sun, as it orbits about 1.01 AU from its star. This is almost the exact same distance as the Earth is from its sun. It also has an estimated temperature of around 292 Kelvin, or 66 degrees Fahrenheit. These qualities of Kepler 98 and its solar system have scientists focused on finding meaning behind the parallels between it and the planets in our solar system. While Kepler 98 may not be able to host life, its conditions make it possible so that if it were to have a moon, or even multiple moons, they could have the potential to harbor life themselves. Hope all of you enjoyed the tour. Just know you're welcome to come by at any time.